This is the section 2.5, extra examples. This will probably be part 1 of this because we still have some of 2.5 to cover on Monday's class, and there's a good possibility we may have a couple more examples that need to go into a video. This is an absolute value equation. This was example 1, part C. We need to isolate the absolute value, so we'll subtract over that 5. As long as the number on the other side is greater than or equal to 0 or positive or 0, you can then solve this. So x minus 2 equals 0 is the only possibility because you can't make 0 positive or negative. Normally we would have 2 cases, but in this case this is the only time an absolute value will have a single solution. Looking at example 2, I didn't get both of these done in each class, so I'm going to go through them again. These are factor by grouping problems, just to make sure you notice that when you have 4 terms, that's a good option to try. Pull out an x squared out of the first pair, get a 3x minus 4. The second pair starts with a negative, so you have to pull that out, and they have a 9 in common. If you divide that out of both, you will get 3x minus 4. Notice that that gives you a 3x minus 4 as one solution, but the second solution factors again because it's 2 perfect squares with a minus. So now we have 3x minus 4, x plus 3, x minus 3, all equal to 0. Please don't drop the equal to 0 part. And you would set each one equal to 0 and solve. So we will have 3 different solutions. This one would be 4/3, negative 3, and positive 3. For the second one, you have to get this equal to 0 first. So that would be the first move. Subtract everything over to one side or add, depending on the signs. And I can pull out a GCF here. X squared, everything has x squared in common. So that would leave this as 15x to the third minus 20x squared minus 6x plus 8. Factor by grouping on the remaining pieces, pull out a 5x squared. That would leave us with 3x minus 4. Pull out a negative 2. That will leave us with 3x minus 4. All that's in a big bracket. Here's our x squared we pulled out. So now our factors are x squared, 3x minus 4, and 5x squared minus 2. If you set each of these equal to 0, we will get that x squared equals 0. If you take the square root of both sides, that's just going to give you 0. No plus or minus needed since 0 is neutral. This would be 4/3. On this one, you have to move everything over first and then take the square root. But when you take the square root, this is not a 0, so you do have to put plus or minus, and this has to be rationalized. So we would multiply top and bottom by square root of 5, so that's square root of 10 over 5. So that one's a little bit tricky because of the final answer. Okay, the only other thing we need to do, because example 3 is part of the notes for Monday's class, is we need to look at some more radical equations. These are some of the ones we skipped over in class. So notice that for A, it's already got an isolated radical, so we use the power rule to square both sides. That leaves us with 2x minus 9 equals, do square both top and bottom of the fraction, so that would be 1/9. You could multiply everything by 9 if you want to get rid of that fraction, so that would be 18x minus 81 equals 1. We would add the 81 over, that would be 82. Divide by 18, and both of those are divisible by 2 at least. So if you divide by 2, that would be 41 over 9. We need to check that solution. So square root of 2 times 41 over 9 minus 9 equals 1/3. This would be square root of 82 over 9, and you can make 9 be over 9 as well, so that would be 81 over 9. And that gives you 1 over 9 under a radical, which when you take the square root does equal 1/3. So 41 over 9 is the correct solution. We did B in class, so let's look at C. First step would be to raise everything to the 4th power to get rid of that 4th root. So that's 2x squared minus 1 equals x to the 4th. It looks kind of quadratic, so I'm going to move everything over to the right side to be with that x to the 4th. And then this factors into x squared and x squared. The reason for that is this power is double this one, so it should split evenly. And then this would be a minus 1 and a minus 1. And then both of those factor into x plus 1, x minus 1, x plus 1, x minus 1 being perfect squares. So essentially we get x equals -1 with a multiplicity of 2 because it appeared twice, and x equals +1 with a multiplicity of 2. But we need to check to see if these answers work. So the 4th root of 2 times -1 squared minus 1 equals -1. A 4th root cannot equal a negative answer. That just doesn't make sense, so that one doesn't work. You could work it out, but it's not going to work. Even roots do not equal negative numbers. And then when we plug in the other one, we get, this is 2 times 1 minus 1, so this is the 4th root of 1, which does equal +1. So one extraneous solution and one solution that does work. We did D in class, so let's look at E. Need to get the radical on one side by itself, so move over the 3. Square both sides. That's the power rule. This squared means we have to FOIL it. So over here you can think of doing x minus 3 times x minus 3. That would be x squared minus 6x plus 9. The right side, the radical cancels and leaves you with 5x minus 9. Move everything to one side. And that would give us plus 18. So this is going to factor into x minus 9 and x minus 2. Which is x equals 9, x equals 2. Plug them back in. If you want to, you can plug them back into this line. Sometimes that's easier to factor, just ignore the red parts, or to check. So this would be 9 minus 3 equals the square root of 5 times 9 minus 9. That's, 6 equals 45 minus 9. That is the square root of 36, which does equal 6, so 9 is definitely a solution. But 2 minus 3 equals the square root of 5 times 2 minus 9. It's a times. That's -1 equals the square root of 10 minus 9. -1 does not equal that because the square root of 1 is +1. So 2 does not work. So just a single solution. What I'll probably do in class to start off on Monday is we'll probably do F and G together. F because it's just going to drive home this idea of having an X on the outside. Usually means you have to factor something. And then what do you do if you see two radicals? Then that'll leave us to go through example 3, which we skipped over just a minute ago, and then we'll talk about these quadratics in disguise. And then we still have one problem to do from 9.5 that's going to be on the first exam, so it may get covered on Monday or it may have to be covered first thing on Wednesday. We'll just see how we go through class time. And don't forget you have a quiz on sections 2.1 through 2.4 on Monday morning. Or Monday afternoon if you're in my afternoon class. So I'll see everybody then.